nowadays, a lot of decision making relies on geospatial data, right? Look at monitoring climate change, GPS. Having accurate data for that kind of application is very, very critical, especially for situations like natural disaster, where decisions that affect the lives of people hinges on the very notion of data integrity.
Hi, I'm Stephanie Tumampos, and you're listening to Down to Earth, the show where we talk to incredible geoscientists about their science and its impacts on our planet. Today, we're diving into the nitty-gritty of data integrity and why it's so important for everything we do in the geosciences, particularly in the realm of AI and machine learning. This episode of Down to Earth comes from the Earth Science Informatics Technical Committee of the Institute of Electrical and Electronics Engineers Geoscience and Remote Sensing Society. The Earth Science Informatics Technical Committee brings together informatics experts and practitioners to support open science and maximize science data use for research and applications. To learn more about this technical committee and how you can get involved, visit their website at grss-ieee.org/technical committees.
I split my time between NASA headquarters and NASA Marshall Space Flight Center. I work on various activities related to data systems, advanced technologies, computing environments. So yeah, a lot of projects.
This is Dr. Manil Maskey. He's a senior research scientist with NASA's Earth Science Division. For over 20 years, Manil has focused on research and application in the area of data systems, machine learning, computer vision, and visualization. Currently, Manil is developing an artificial intelligence and machine learning strategic roadmap for the Earth Science Data Systems program at NASA headquarters.
There are about 4+ million people that we serve who are using our data. Data systems is a big user base, and there's always issues with data access, data processing, data analysis.
Because data integrity is so essential to making the most of AI, Manil spends a lot of time thinking about data. From his perspective, there are a lot of exciting challenges facing scientists when it comes to preserving data integrity, particularly with the rapid advances in technology and data access. So let's start with the basics. What is meant by the term data integrity?
Yeah, so generally speaking, data integrity means that it is protected from unauthorized changes, right? And it ensures that it is reliable, consistent, and ultimately it's correct.
Mm-hmm. And what about the term data stewardship? Is that different from data integrity?
So data stewardship is an overall practice of making data accessible, searchable, and then ultimately usable throughout the entire data lifecycle. Data usually has a life cycle. You have missions or researchers generating this data, and they do some QA, QC processes and make it available for public to use. But before you can do that, you have to properly archive it, create metadata, and people usually use that data for research or applications and ultimately create another set of data as an output. Now that data becomes an input, and you have to again go through the same cycle of creating metadata, making a search and discoverable. So that whole practice is called the data stewardship. And it has existed for a long time, and it has evolved as the technology has evolved. And I think it's a big component of data systems, and now it's a big component of AI and ML.
Okay, so what are the challenges scientists are facing with respect to data integrity?
So there's truly a big data problem within the earth science because of all the sensors that are out there, data being collected at such a high rate. So data is constantly gets moved around, right? Sometimes the data is in data center, and we run out of infrastructure to support that. So we add new infrastructure. So data needs to be moved from one location to another. And hardware can affect how you store the data, right? Fundamentally, your bits can change. And I should probably tell you that there are different types of integrity, right? There's logical and there's physical. So what I talked about just now is the physical aspect, moving from one physical infrastructure to another. And on the logical side of things, databases are constrained by things like missing values in the data. You can get biased data. If it's a classification problem, you may have a very dominant class being represented in the data, right? So ultimately, what you want to do is the data that you collect, generate, and store is what the users retrieve. This is the exact same thing. And the way you store physically and logically can have effect on how people retrieve and the integrity of that data.
So, you've just listed many ways in which data integrity can be compromised. And a lot of it really comes down to simple technological or human error, like data corruption during data transfer processes. What about data integrity issues that stem from maliciousness? Especially in our fake news era, I feel like many people doubt science because they think there are malicious forces involved in data corruption. So, what are your thoughts?
Yeah, we hear a lot about data being compromised, right? Data being stolen. So there is a difference between data security and data integrity, and public perception of that is that that's mostly data security. Data security usually means that there is a protection around data from unauthorized use. Data integrity, on the other hand, is always a question of reproducibility of that particular research result. So to achieve that reproducibility of the results, we need to have a proper data integrity model and have researchers follow a proper data integrity checklist.
Mm. It's really important that you mentioned about data security and data integrity. I think a lot of people, even me, I guess, would interchange data security and data integrity. And there's, I think, not even a fine line. There's a very, very thick, broad line between those two. So I'd like to dig in a little further, particularly with respect to AI data sets and training models. If we could take a step back, I'd like to first ask for those who don't know, what are AI training data sets and models? What are they used for?
Right. So the AI and machine learning algorithms learn from data, right? That's their whole purpose of learning from the data. Usually they find relationships within the data, and ultimately they develop the understanding of what's in the data and try to develop this decision making process. And they do so by learning from the data and comparing against the confidence, right, of the decision making process by using the data they are given. That data that are given is the training data. And usually it has some sort of truthness to it. And in most cases, those are labels, right? Saying that this pixel is this, or this scene is this. Ultimately, the mathematical algorithms that learn the patterns in the data or learn to classify or learn to predict from those training data sets are stored in something called training model. So the models basically is an approximation of the data that are given, and they learn how to make decisions like any of us would do. And that digital object is the model.
That makes sense. So, who makes sure these training models are accurate? And how does that work?
As a general machine learning community, when people submit their publication, they're starting to have these challenges. Who can reproduce the same result, right? As part of that is when people publish papers with supreme accuracy and improved accuracy and some applications, you're required to publish your code, model, right, and your training data. And there are initiatives around that to replicate that, challenge that, right? And that in itself becomes a publication. Integrity usually means that you should be able to replicate what people have done, right, and get the same result. If the data has integrity and the model has integrity, then you should be able to do that. And it's yet a very difficult problem so far,
Why is it so difficult?
because much of the focus for the past decade has been developing these algorithms that produce supreme accuracy, right? What people have realized now that is if you improve your data that the algorithms learn from, maybe the algorithms that we have are good enough. We just need to improve our data, right? There are mislabels in the data related to integrity. There are biases in the data related to integrity, right? So there are people are now working on formulating challenges that actually improves the data, not the algorithm, right? So data is getting more and more important, and I just hope that the standards community and the people working on the metadata standardization work faster to come up with standards so that we can describe our data sets easily so that it's more interoperable, right? If we have standards, we can make it interoperable across various domains and across various users, and we can develop a tool around it. And fundamentally, if you develop an algorithm, models, data, if you can share it in a standard way, that just adds to the reproducibility of that. And one day maybe operationalization of your algorithms and the use cases, which is the ultimate goal, right? The application side of things is the ultimate goal.
Up next, Manil shares the ways the scientific community is tackling standardization when it comes to data integrity.
Are you looking to make an impact in geoscience and remote sensing science? Then consider joining one of the Geoscience and Remote Sensing Society's technical committees. From environmental analysis to spaceborne imaging spectroscopy, each technical committee advances innovative research and technology in a specific field of remote sensing. By joining, you'll connect with a community of passionate researchers and professionals who are fostering important international collaborations and steering global research agendas. You'll also gain access to the latest news and state-of-the-art research in the field. Expand your network, enhance your career, and make a difference. Join a GRSS technical committee today by visiting grss-ieee.org/technical committees.
Welcome back. Today, we've been speaking with Dr. Manil Maskey, Senior Research Scientist with NASA's Earth Science Division. We've been discussing data integrity, particularly within AI and machine learning datasets and training models. Data integrity is incredibly important in the geosciences, especially for making accurate decisions about situations like natural disasters. And as Manil pointed out, there are several technological and human errors that can impact data integrity. As always, in the face of a challenge, the scientific community is stepping up to find ways to mitigate these errors and increase the replicability of data. How are they doing this, you ask? By developing international standards. You mentioned before about standardization. So, what are the current conventions or standards we're using to ensure integrity and stewardship of data?
In terms of standards, as far as I know, there isn't one for machine learning training data and models. There are practices like FAIR, right? And people are relying on that as an overall guiding principle. However, there are funded work, and projects within the standards community to develop standards. One that comes to mind is Open Geospatial Consortium, OGC, and they've developed standards for various geospatial services, metadata, data storage, archives, distribution, right? And even some characterization of how things are linked. I believe ISO is also working towards ML data standardization, but it takes a long time. That's the thing here, right? The AI is moving so fast, and the standardization process, which requires consensus from academia, government, industry, and getting that consensus takes a long time. So as with any technology, if people latch onto it and it moves fast, and then we run into this situation where sharing knowledge and results becomes an ad hoc process rather than a standardized process.
Mm. I love that you mentioned FAIR policy because I was going to ask about that. For listeners who don't know, FAIR stands for findability, accessibility, interoperability, and reusability. So I'd like to ask Manil, in your opinion, how can the FAIR principles help us with data integrity while we wait for standards to be developed?
I think fundamentally you need to be able to share that knowledge so that people can replicate it, reproduce it, and use it in some application, right? And benefit the society. So in terms of FAIR, I think metadata and standardization are the key enabler. And again, we're working towards that, but not there. There are initiatives around the world to discuss these kinds of issue in public forum. And we meaning the GRSS has sponsored many workshops, right? Summer schools that focuses on making people aware of, hey, if you're working in the field of AI, these are the things you need to do so that people can reuse their information, right? The other side of things is tools are already developed. For example, TensorFlow, PyTorch, right? They expect data in certain way. So we'd have to create awareness around those as well. Hey, just because you create a training data set for images doesn't mean people will use it, right? Because in practice, people are very familiar with TensorFlow and PyTorch. Maybe you should take an extra step to convert your training data set into these chips that TensorFlow and PyTorch will accept. And we're creating those awareness using summer schools and trainings. It's ultimately making sure that whatever research results are, we can reuse that and ultimately use it in an application that has some societal benefit.
I think you're right. So, in terms of data integrity and data stewardship as a whole, what do you see as the future of this work?
In terms of data stewardship as a whole, it is an ongoing process. It's a cyclical process, right? We know how to version and provide stewardship of source code, i.e. GitHub, and we know how to version and provide stewardship of data. So model comes in between. So it creates this whole area that we haven't charted before. Data are moving from on-premise to cloud, right? And cloud means it's more democratized now. Now anybody can go and access, create solution on top of that data, right? And so to do that, people will reformat the data. People create a highly efficient way to store the data. Now, is that data same as what was intended by the researchers or the mission that generated that data? We don't know, right? There's only way to find out is tracing it back to the original data, right? And these create a lot of exciting areas for research, and hopefully people tackle these problems in near future and come up with solutions for us to use down the road.
Well, that's all for this episode of Down to Earth. Want to learn more about standardization and data integrity? Then connect with the GRSS Earth Science Informatics Technical Committee at grss-ieee.org/technical committees. To learn more about Dr. Manil Maskey and his work in this area, follow him on Twitter at @IamManil or find him on LinkedIn. Don't forget to follow us on Spotify and Apple Podcasts and send some love to our sponsors at IEEE_GRSS on Twitter and Instagram and IEEE Geoscience and Remote Sensing on Facebook and LinkedIn. This episode was produced by Nicole Bedford from Nicole Bedford Films with help from me, Stephanie Tumampos. Graphics and design by Mylene Briggs of Killam Media. And a special thanks to Fabio Pacifici and Keely Roth for their support. I'm Stephanie Tumampos, and you've been listening to Down to Earth.